Are you familiar with version control or version control systems? Here's a quick example of where they're useful. Have you ever opened an app on your phone and received a prompt to update to a new version? These prompts most likely direct you towards an app store where you then download the latest version. As you download the new version, you might notice a new layout, button, or piece of functionality. In software and web development, developers use version control to track the differences between versions. And a popular method of tracking versions is the use of version control technologies like Git and GitHub. In this video, you'll discover the answer to the question, what is Git and GitHub? You will learn about the differences between Git and GitHub and how web developers make use of them, and explore the benefits and advantages of both services. Let's start off with Git. Git is a version control system designed to help users keep track of changes to files within their projects. Git was designed to address the challenges that its creator, Linus Torvalds, was having managing the development of the Linux kernel, the operating system for Linux. Linux has thousands of contributors who commit changes and updates daily. Git was designed to help with the challenge of tracking all these changes and updates. As well as helping to keep track of changes, Git was also designed to tackle some of the shortcomings of other version control systems. The benefits that Git offers over similar systems include better speed and performance, reliability, free and open source access, and an accessible syntax. It's also important to note that Git is used predominantly via the command line. Developers tend to find Git syntax and commands easy to learn. The other service commonly used by developers is GitHub. GitHub is a cloud-based hosting service that lets you manage Git repositories from a user interface. A Git repository is used to track all changes to files in a specific folder and keep a history of all those changes. It incorporates Git version control features and extends these by providing its own features on top. Some of the most common of these features include access control, pull requests, and automation. You will learn more about these later in this course. The features are split out into different pricing models to suit different size teams and organizations. It's also important to point out that GitHub is very popular among web developers. It's like a social network. For example, projects can be private or public. Users on GitHub have their own profile, which other users can follow. Public projects can accept code contributions from anyone across the globe. And it also includes multiple features outside of its core development tools, like documentation, ticketing, and project features. You're now familiar with Git and GitHub version control systems, along with the benefits and advantages that they offer. This is just the beginning of your version control journey with Git and GitHub. Great work. Okay. So I have just logged into the GitHub website. Once there, I click on the green button with the text Create Repository. When I click on the button, I am redirected to the Create a New Repository screen, where I'll be prompted for who the owner is. I choose my account as the owner option for this example. Next, I need to input a repository name. So I type a name called my-first-repo. Notice that the input field has a green tick icon beside it. This is just GitHub letting me know that this name is available to create the repository. If it's not, I will see an X icon and be prompted to rename it. Okay, so now I need to type a value for the description input. For this, I type practice account for learning Git. The next option I want you to know about is if you want the repository to be public or private. Public just means that anyone on the internet can see the repository. I still have control over who can make changes to it. It's just available on the viewable aspect of it on the internet. The next option is private, meaning it's not available for anyone to see. I can only allow access by granting people access to the repository. The next few options are about initialization. I can initialize a repository with a README file, a git ignore file, and a license if one is required. For now, I'm just going to choose the README file option and then click the Create Repository button. Okay, so a repo has now been set up, and I can see that I have one single file in the repository called readme.md. MD is just short for Markdown, a popular method for creating documentation because it's shorthand for creating HTML pages. This allows me to do things like creating titles and texts. I can insert images and various other web page elements. Notice that the main branch has also been created, and it's important to know that every repository you create will have a single main branch at the start. This is also known as the main line. Next, I'm presented with additional button options. The first is labeled Go to File. Then there is Add File, which you can use to add a new file from the UI. And finally, a green button labeled Code. Clicking this button provides me with the GitHub UI options for cloning down the repository. First is the option for HTTPS, which contains the HTTPS URL of the repository. And I can use this to pull it down by using the git clone command. Next, there is an option for SSH, but to use that, I have to set up my SSH keys and assign them to the user accounts. And finally, I have the GitHub CLI option. Underneath, notice that there are additional options for GitHub Desktop if I would like to use that. And finally, I can also download a compressed zip file containing all the files and folder structures. For this demo, I will show you how to use HTTPS. To begin, select the HTTPS option and click on the Copy button to copy the HTTPS URL for cloning. Now I go to my command line that I will be using to run the commands to clone the repository. I'm currently in my home directory. Okay, so what I usually like to do is create a directory for all repositories that I'm working on at the moment. First, I create a directory using the command makedir. Then I type the name of the directory I want to create, which is projects. Next, I can cd into that, and now I can run the commands to clone the project from the GitHub UI. To do this, I type the command git clone and paste the HTTPS URL I copied earlier. Finally, I press Enter on my keyboard. Notice that I receive a message stating that Git is cloning into the My First Repo folder. It then displays messages about all the objects that have been received. It also displays a 100% status message and then finally a statement that simply says done. Now I can list the directory by running the ls-la command, which means list all directories. Notice that I have my repository, which I named My First Repo. This is the name of the repository that we set up on GitHub. Finally, if I enter inside that folder using the cd command, I can see a single file, the readme.md file. If I use the ls-la command, another file is listed, which is just named .git. You will learn more about this later when you explore how to use this for source control. As you now know, GitHub is a cloud-based hosting service that lets you manage Git repositories from a user interface. It's like a social network. You can follow users or accept code contributions from anywhere in the world. In a previous video, you created and cloned a repository to your local device. I am now going to explain to you how to pull the repository to your local device. I will be demonstrating commands that you can use in Git Bash Shell for Windows users and Terminal for Mac users. This refers to the application where the commands are typed in. Let's move to the directory I want by typing cd and the name of the directory, My First Repo. Once inside the directory, run the list all command by typing ls -la. -la is short for list all. There are 4 items in this directory. I will focus on 2 of them, the .git item and the readme.md item. Let's start with the readme.md file. This item was added when I created the repository on GitHub. The other item is a folder called .git, which is a hidden folder used to track all the changes. In Linux, any folder starting with a dot is a hidden folder. This folder is automatically created when you create a repository, and you will learn more about it later in this course. In the command I ran, I added the switch -la so we would list all files and folders, including the hidden ones. The .git folder is initialized by running the git init command. As the repository was created on GitHub, it was not required for us to run it. GitHub handled all of this as part of its create new repo flow. Now let's focus on Git workflow. Git uses workflows which can be broken into 3 states, namely modified, staged, and committed. Now I will go over each state and then provide an example of adding a new file to my Git repository to show it in action. Let's start with the first state. Adding, removing, and updating any file inside the repository is considered a modified state. Git knows the file has changed, but does not track it. This is where the staging state comes in. Let's turn to it now. In order for Git to track a file, it needs to be put in the staged area. Once added, any modifications are tracked, which offers a security blanket prior to committing the changes. Then, the last state is the committed state. Committing a file in Git is like a save point in many ways. Git will save the file and have a snapshot of the current changes. Let me introduce you to an example that summarizes the workflow clearly. Suppose you have a workflow that contains the 3 stages just mentioned, as well as the remote repository. A file is added from the working directory to the staging area. From there, the file is committed and then pushed to the remote repository. From the remote repository, the file can now be fetched and checked out or merged to a working directory. You will learn more about this later. Well done! You've covered some of the Git fundamentals and now know what is inside a Git folder and understand the Git workflow. So, I've opened up my terminal window. I'll have a look at what directory I'm currently located in. I can do this by running the pwd command, which is short for print working directory. Notice that I'm in the directory my first repo. Now I can check inside that directory by running the ls-la command. I can see that I have 2 items, a readme.md file and a hidden folder called .git. Before I add any files or make any changes, it's always good practice to check if any changes or commits are currently there. I can do this by using the git status command. Git status also displays what branch I'm on. In this instance, I'm prompted that I'm on the branch called main, and that my branch is up to date with the origin main. This means that all the latest files on my local machine are exactly the same as what is displayed on the GitHub UI, which represents the server that everyone commits to. Git status also tells me that I have nothing to commit and that my working tree is clean. Now, let me show you how to add a simple text file. I'll add a file called test.txt by using the command touch test.txt. Then I'll run the command git status again. Now, Git is telling me that I have an untracked file, which is the test.txt file that I just added. It's also telling me that I have nothing added to the commit, but that untracked files are present, and that I should use git add to track them. The purpose of the git add command is that I'm essentially prompting Git and letting it know that I want to track this file, and that it'll be included as part of my commit. The first phase of this process is just to run the command git add test.txt. Now I'm going to run git status again to check that file is now being tracked. Notice again that I'm notified that my branches are up to date. But it's also telling me now that there are staged changes to be committed, which is this new file called test.txt. It prompts me asking if I want to revert those changes. For this, I can use the git restore command with the flag --stage and the file name test.txt. Running the command will unstage the file from the commit. I then run git status one more time to see the file is back to an untracked status. So once again, I'll add the file using git add test.txt, run git status, and now notice that the file is back in a tracked state. Okay, let me clear my screen before moving on. To do this, I use the clear command. Now any changes that I make from here on will be tracked. And then at the end, I will use the git commit command. The staged area is really important because you're essentially preparing to get all of the files and changes that you want as part of whatever feature you're working on. Basically, you are getting all of that content ready for commit. You also have to remember that this is only on your local machine. The distributed manner of Git means it will only push to the server using the actual push command itself. But any change you make here is only specific to you and your local machine. Anyone else who pulls down the project from GitHub will only get what's available on the remote server. Okay, now I want to explain to you how to run the git commit command. First, type in git commit. You can pass in a flag of -m, which stands for message, allowing you to type in a message which will be attached to the commit. In this example, the message is adding a new file for testing. Next, press return on the keyboard, and now notice that the response states 1 file change, 0 insertions, 0 deletions. There is also a create mode statement with the name of the file, test.txt. Finally, if I run the git status command, the response says that there is nothing to commit and the working tree is clean. However, I want to be aware of the message at the top of my screen. This message tells me to use git push to publish my local commits. And this ties back in with what I mentioned earlier. All of these changes are on my local machine, and they will only be uploaded to the remote server when I run the push command. You learn more about the push and pull commands in a future lesson. Okay, I've opened my command line. I should check to ensure that I'm in the correct directory using the pwd command. I can see that I'm in the My First Repo directory. Now, it's good practice to perform a git status command to make sure that I have no commits outstanding. If there are no commits and the shell is clear, then my branch will show as up to date with origin main outside of the main branch itself. So my next step would be to create a new branch. To create this new branch, I use the git checkout command by typing git checkout-b. I then call this new branch feature/lesson, which I'll refer to as feature lesson for the purpose of this video. But this is just one way to create a branch. I could also use git branch and pass in the name as well. These methods are the same and can both be used to create a branch. The key difference between them is that git branch just creates a branch, but git checkout-b moves me from the main branch into the branch that I created. I can verify that I've been moved between branches by running the git branch command. This will then tell me if I have switched from the main branch to one of the feature lesson branches. Any changes that I make will now only occur in this new branch. It's important to remember that the main branch has no indication or knowledge of any of these changes, even when I push code to the main repository. This is because that branch exists in isolation. The new branch needs to be merged back into the main branch to recognize changes in the feature lesson branch. This is where it'll come in with a pull request. The purpose of a pull request is to obtain a peer review of changes made to the branch. In other words, to validate that the changes are correct. When coding, many teams will have conditions around the unit tests and integration tests. These conditions will usually include validating that the standards have been met for merging back into the main line. A team will also check for any issues that might have been missed. The next step is to add a file to the new branch. I can create a simple text file called test2.txt using the command touch test2.txt. Then I add it using the git add command. I then commit it using the git commit command. Once I've committed the new file, I need to push my changes up to the remote repository with git push. I type git push-u origin feature lesson. It's good practice to specify -u. This means that I'm only going to get updates from the upstream, which in this case will be the main branch. The result of this is that the origin won't be my main branch anymore. Instead, it's feature lesson. I press the enter key and this pushes the new branch up to the remote repository. As I am using HTTPS, I will be prompted for my login information. Once this action has been completed, GitHub will recognize that a new branch has been added. It will then prompt me to create a pull request that can be compared against another branch, in this case, the main branch. So my next step is to open the GitHub UI. GitHub will show my new branch with a prompt. Click on the Compare and Pull Request button. A pull request lets the team know that I've made new changes that I want them to review, and that I also want to approve or request changes to the actual pull request itself. Another thing to note on the GitHub UI is that I'm comparing this with the main branch. I've essentially cut a branch from the main called feature lesson. I've then added a new file called test2.txt, and it's this file which is the main difference between the two branches. Next, I check the pull request. I can see that there's been one commit. In other words, just one file has been changed, and it's been added as test2.txt. I then click Create Pull Request. The team will then review the changes and either approve or decline them. Once approved, you can then merge your changes to the main branch. This is much cleaner than everyone working off the main branch. It's particularly useful if you have features that are closely tied together. For example, you could be working with a feature that crosses over with some code or requires changes that most likely will be altered by someone else. So, the approach of keeping everything at branch level is much easier than having everyone working from the main line. In fact, everyone working off the same branch is more likely to cause issues. Having independent branches makes the project easier to manage. Also, there's no limit to how many branches you can have. The team decide on the naming conventions that they use. In a lot of cases, when adding a new feature, you can add the keyword feature, then followed by the branch name, like a URL path, such as feature/lesson in this example. For bug fixing, fix/ can be used. So, because we have no reviewers in my current project, I'm just going to merge the branch. Then I'll confirm the merge. Once confirmed, I'm presented with the option to delete the branch. On your own projects, it's up to you whether you want to keep the branches or delete them. For now, I'm going to keep the branch. Then I can return to my code where the test2.txt file has merged into the main branch. I can then confirm that by going back to my command line. Next, I look at Git status again to check if there's something to commit. At this point, there's nothing outstanding. I'm still on the feature lesson branch. I can check out my main branch by typing git checkout main. Then I run the git pull command. I'll then receive the latest changes that were merged in from the feature branch that I just created. Notice that the test2.txt file is now available. I can also verify that by doing a simple check within the directory by using the ls command. This returns a README file, test.txt, and the test2.txt, which is from my branch. You have now learned the branching workflow, which you'll use regularly when collaborating with other developers. In the pre-internet era, saving project files to different machines for backup and transfer was a tedious process. It required manually copying files between machines one at a time, making things slow for teams. Nowadays, the cloud has enabled a more efficient way to do this. And in this video, I'll explain the differences between remote and local on GitHub. You have previously learned about the flows modified, staged, and committed in a Git workflow. Now you will learn about pushing your changes from your local to a remote repository. Remote refers to any other remote repository to which developers can push changes. This can be a centralized repository, such as one provided by GitHub, or repositories on other developer devices. In this lesson, you will be hearing some new terms, such as clone, push, pull, and repo. Don't worry, these will all be explained soon. The remote code is accessed through a URI, which is unique and only accessible to those who have permission. Local, on the other hand, refers to your machine, which can be a laptop, desktop, or even a mobile device, and is only accessible to you. To demonstrate both of these in action, let's say we have a project called Coding Project 1, which is located on GitHub with a unique URL. In other words, this project is stored on the remote server. When a user wants to copy this project to their local device, they need to either perform a clone, if it's the first time, or pull it to get the latest changes. To clone a project, a user must first choose a folder on their local machine. Coding Project 1 is then cloned from the server and copied into the chosen folder. The user can then make changes to the project and push those changes back to the server. Other users working on the code base won't see those changes on their local machines unless they pull the latest changes from the server. One of the advantages of Git is that you can work offline and then commit your changes when you are ready. Now, let's go through an example of how exactly you would do this in GitHub. In this video, I'm going to explain what local and remote mean in GitHub and help you to understand the differences between the two. First off, I'm going to create a new local repository using the git init command. I'll start by inputting mkdir to create a new directory, and then I'll set the name as my second repo. Next, I'll use the change directory command, which is cd, followed by the name that I just set. Finally, I'll perform the git init command to create my new repository. This will return a line telling me that an empty repository has been initialized under root, projects, my second repo. If I execute another command called git remote, it comes back as blank. The reason for that is that I've only initialized a local repository which has no connection to a central repository that sits either on GitHub or another server. Right now, it's only available locally on my machine. Now I'll step back out from this directory and go into my first repo with the cd command again. This is a repository that I created earlier and does have a connection to GitHub using the remote URI. I'll then check it by using the git remote -v command. Git tells me that it's set to git tutorials 101 myfirstrepo.git. Next, I'm going to set this against our second repository. I'll step into the new directory once more using the cd command. In this case, we're going to add this URL to the remote settings by using the command git remote add, specifying a name and then passing in our URI. The name that is typically used here is origin, so I'll stick with that. So again, the full command with the URL should read git remote add origin git at github.com git tutorials 101 myfirstrepo.git. This time when I execute the git remote -v command, I have this set up against the git tutorials 101, which sits up on GitHub. What I'm going to do next is use the git pull command, which will connect with the GitHub server and pull down all the changes from the repository. So on my local, I now have all the changes, but when I check the directory, it's blank. The reason for this is that I haven't set up a branch that matches with what I have on the server repository. Fortunately, I can change that by performing the command git checkout main, which will set up a branch main on my local that tracks the branch main from the remote. And now when I check my folder using the ls command, it confirms that I have the readme, test, and test2 files available on my local. In this video, you learned about the differences between local and remote in GitHub. This will help set you up to exchange data more efficiently within your development team. See you next time. By now, you should know how to use git add and git commit to add new changes to your local repository, put them into the staging area, and get them ready for a commit. Now, let me guide you through the next step and upload these changes to the remote repository using git push. I'll also demonstrate how to retrieve changes from the remote servers and apply them to your local repository with git pull. Before we begin, let's go over the command line and perform the command git status. Git tells me that I'm on the branch main, but also that my branch is ahead of the origin main branch by one commit. What this means is that all the changes that I have on my local repository are currently ahead of what is stored in the remote repository on GitHub. That ties into Git's distributed workflow in which you can work in an offline state and then only ever communicate with a remote repository when you use the commands of git push or git pull. Now I'll guide you on pushing your changes to the remote repository, and then I'll demonstrate how to use the pull command to get the latest changes. It's always good practice to check which branch you're currently on, and you can use git status or git branch to do this. This is important because if you do make changes in a different branch, you need to specify where you're pushing up to. So let's push up the changes using the git push command. I'll specify the origin branch to be the main branch, as in I'm pushing my changes to the origin as the remote repository, and then I want to push it to this branch as the main. I'll be prompted for my login information as I am pushing using HTTPS. Once I enter my login information, you'll notice that the commit is pushed from the local main to the remote main on the remote repository. Let's refresh the page on the GitHub website. You can see that my test.txt file now appears there. That's taken the commit snapshot that I have in my local repository and pushed it up to the remote repository. Git has then compared those files with what's on the remote repository to find any conflicts or problems. If none are found, it'll just merge them straight through, which is classed as an auto merge. If there are any conflicts, my push will fail. Before doing a push, it's also good practice to perform a git pull in order to get the latest changes from the remote repository and reduce the odds of encountering a conflict. Because I only have a single file and this will be a new repository, I'm not going to run into any conflicts or any issues. So now let's move on and I will guide you through how you can use git pull. Normally, when you're working on a project, you could have several developers all submitting with different branches, different code, and different features. In order for you to get those changes, you need to use the git pull command. To demonstrate this, I will add a single line to the test.txt file using the GitHub UI and then add the commit change, updated the test.txt file. I'll then commit it directly to the main branch by clicking on Commit Changes. The changes now appear on the UI, but because I haven't used the git pull command on my local machine yet, I should have no content on the test.txt file. Let's verify by using the cat command on test.txt, and sure enough, the file is empty, which is what you'd expect. As I mentioned before, I need to run the command git pull. This will get the latest changes from the remote repository. If any new changes were added, it'll be reflected in the shell output. I run the command, and in this case, Git tells me that one file has changed with one insertion. If I run the cat command on test.txt once more, it shows that the line "This is my change" is now available in my local directory. With git pull, you're taking all that data from the remote server. Git then merges the snapshot from the remote with the snapshot that's on your local. It will auto-merge them if there's no conflicts. Once that's complete, I'll have the latest changes on my local machine. You have now learned how to push to and pull from your GitHub repository. Have you ever applied for a job? You know the process. Prepare your resume, look for jobs, submit an application, prepare for interviews. That is an example of a workflow. In computer programming, workflows are really important. By the end of this video, you will be able to describe what a workflow is, and you will also be able to identify different workflows available. Now, let's start with an example to illustrate why workflows are important. As a developer working on a project, you first need to pull the project down from a remote repository to your local machine. This is commonly called checking out a project or pulling a project. Once on your local machine, you can build and run the project and make changes. When you are done, you have to push the changes you made back to the remote repository so other developers can see them. From this example, you can understand that the purpose of a workflow is to guide you and other members of your team. It should not disrupt or cause blockers for deployment or testing or for any other developer who contributes to the project itself. Choosing a workflow needs careful consideration. It can depend on the size of the team, the culture of your workplace, and also the type of product you intend to build or update. With that in mind, let me explain feature branching, a common workflow used by many developers. Feature branching means you create a new branch from the main line and work on this dedicated branch until the task is completed. Rules and conditions need to be made in order for this branch of code to be kept in a good state. Every code base has a main repository, which is essentially the source of truth for the application. All changes, such as add, edit, or delete, are submitted directly to the feature branch. The main branch stays as is. When you are ready and happy with the code you have added, you have to commit the changes and then push to the server repository. To commit, you push the changes, and as it's a feature branch, a pull request follows. The pull request is compared to the main branch so developers who peer review the code can see exactly what was changed. Once it's reviewed and approved, it can then be merged into the main line. Now, let me guide you through how this works using Git and GitHub. Before creating a new branch, always ensure you have the latest code. You can do this by running the git pull command to pull the latest code from the remote repository. Next, you need to create your new branch. You can do this by passing the -b flag with the checkout action. Next, let's add new content to this branch. Let's create a readme.md file. To do this, type git add dot or git add readme.md and press enter. Next, you need to commit the new file and provide a meaningful message so other developers can discover what you added. To do that, run the git commit command with the -m option to include a message with a short description of the changes being committed. The file has now been added to the local branch. This means that the file is only visible locally to you. To allow other developers to see the changes, you need to push the file to the remote repository. You can do that by running the git push command and referencing the new file. The changes are not pushed to the remote repository on GitHub. Your next action is to get it reviewed as part of a pull request, but more about that later. And that brings us to the end of this video. Now you know what a workflow is and how a feature workflow works. Well done. Previously, you learned about the hidden folder called .git that is located in each project. You know that this folder is responsible for keeping track of all changes across a project. How does Git know what branch you're currently on? Let me explain. It keeps a special pointer called head, which is one of the files inside the .git folder. This file refers to the current commit you are viewing. You will now learn how to identify the current commit you are working on. First, open the .git folder on your terminal. Type cd.git and press enter. Next, type cat head and press enter. In Git, we only work on a single branch at a time. This file also exists inside the .git folder under the refs/heads path. Let me show you. Type cd.git and press enter. Next, type cat/refs/heads/main. Press enter. After you enter this command, a single hashed ID appears. This single hashed ID is a reference for the current commit. Let's switch branches to see how the head is moved to point to a new branch. Type git checkout testing and press enter. Next, type git branch and press enter again. This moves the head to point to the testing branch. Let me explain how this happens by using a diagram. We have two branches, the main and testing branch. When you run the checkout command, it moves the head to now point to the testing branch. To check the contents of the head file inside the .git folder, you have to enter the less command. Type less.git/head and press enter. You can now verify that the head has changed from main to testing. Now I will demonstrate how Git head works with a simple example. So I am here in the terminal. To see what branch I am in, I am running git branch. When pressing the enter key, I can see I'm on the main branch. To confirm that, I run the cat.git/head command and press enter. That brings me back to the reference to where it actually points to, namely refs/heads/main. In this case, you can see the reference is pointing to the head's main. If I change my branch to feature testing branches above, I use the git checkout command git checkout feature/testing branches. I then go to my head file inside the Git folder by typing cat.git/head. The ref is now pointing to the feature testing branches, namely refs/head/feature/testing branches. Notice that my branch is up to date with origin/feature/testing branches. I'll go back into my main branch by typing git checkout main and then check the reference file inside the main directory using the cat command again, cat.git/refs/ /heads/main. When I press enter, I get a hash ID. This is a reference to the latest commits of that working directory. I can show you that if you make a change to any files within this directory, that this ID will then change after a commit has happened. So let's do a simple update to the README file. You can do this with any editor such as VS Code, or I can also do this by executing the vim command. Type vim readme.md and press enter. When inside the README file, add some text. In this case, add minor update to your my first repo line and save it. Then check the ID again just to verify. Type cat.git/refs/heads/main and enter. If you would like to learn more about Vim, there is a link to an additional reading at the end of this lesson. The ID should be the same because we haven't committed anything. We've just made a change to run the cat command. Therefore, the ID is exactly the same as before. If I do a git status, it is telling me that I have modified the README file. On the screen, the words modified readme.md displays in red. I'll now add that file. The shorthand to add a single file is git add space dot. Type the command and press the enter key. I am then going to do a commit. Type git commit -m for message by adding minor update to the command line and press enter. The data confirms that one file changed, there was one insertion and one deletion. I am using the cat command to verify what is in the reference file by typing cat.git/refs/heads/main. Press the enter key to confirm that the ID is changed. Originally, the ID started with a 8B55, and now it starts with 9C90. Whenever a change occurs for a commit, this ID will then update to be the latest commit for that working directory. And that's Git head. You now know what the purpose of head is. You can also change the head to point to a different branch. Great novels are rarely written in one go and usually endure several drafts before the author is satisfied with the outcome. Of course, there's always the possibility that an idea from an earlier draft will sound good again later. But without a system of organization, it can be difficult to find where this idea is located. Programming is no different, and sometimes you need to revisit old code. In this video, I'll guide you through how to use git diff to compare changes across your files, branches, and commits. You probably know that the git status command tells you which of your files have been changed. The git diff command goes a step further and tells you what exactly these changes are. When used together, you can think of them as a file system. Git status tells you the file names, but to open the file and see the contents, you'll need to use git diff. To demonstrate, let's say you have a text file named cities.txt, which contains the names of cities you visited. You've been updating the list during a tour of South America, but upon returning home, you've lost track of what you've recorded. So, what can you do? Well, this is a situation where git diff makes itself useful. Git diff will compare the previous version of the file with your current one to find any differences. It will then tell you specifically what content has been removed as well as what content has been added to the file. In your cities.txt file, git diff would tell you that you removed one city that was in version A and then added a new one that appears in version B. So, now that you've had a basic explanation, let's go into a more detailed example. In this video, I'll show you how you can use git diff. Diff is used to make comparisons against files on your local repository. It can also be used against commits and against branches. I'll start with a simple example. When I go into my local repository, I'll find a file called readme that I'd like to update slightly. You can do this with any editor, such as VS Code. I can also do this by executing the vim command to enter the file for editing, remove a few words, and then save it. If you would like to learn more about Vim, there is a link to an additional reading at the end of this lesson. Next, I'm going to use the git diff tool to compare the updated file against the head. Because we haven't yet completed a commit, it's not available for a comparison against another commit. So I'll input git diff, pass in the head as the first option, and then finally the file name. This then returns an output showing the changes that occurred in each file. Here, the line starting with a minus symbol represents what it originally was, while the line with a plus symbol shows what it is now. So my example tells me that the words minor update have been removed. In addition to individual files, you can also make comparisons against previous commits. I'll start by using the git log command to display my history of commits, and I'll also use the pretty flag here so that each one is shown in one line. The pretty flag is used by developers to make the output more readable. Each commit has its own ID code, so I'll perform a git diff command on the codes from the most recent commit and from the very first one. Git will go through all the files, note all the changes that have occurred, and return the differentiation between the two. Finally, one more way of using git diff that I'll show you is how to use it for making comparisons against branches. If I perform the command git branch, it will display all the branches that are available in the repository. I can then use the git diff command to pass in my main branch, followed by my feature branch as the second option. And once again, this will display all the changes that have occurred between the two. This shows that my feature branch has the previous update, while the main branch has the most recent one. So these are a few examples of how you can use git diff. In this video, you learned how to use git diff command to keep track of changes across your files, branches, and commits. This tool can help you to stay on top of updates and avoid mistakes or overlap. See you next time. One day you might be overseeing a big team of developers. Can you imagine how complex it gets to keep track of everyone's changes and updates to files? Fortunately, Git has a very helpful command for keeping track of who did what and when. It's called git blame. In this video, you will learn about git blame, and I will demonstrate how it is used with a few examples. One of the core functions of Git is its ability to track and record the full history of changes for every file in the repository. In order to view and verify those changes, Git provides a set of tools to allow users to step through the history and view the edits made to each file. The git blame command is used to look at changes of a specific file and show the dates, times, and users who made the changes. By now, you should know how to use commands like git log to see the changes made. I will now use the feature.js file to demonstrate how git blame works. Let's get started with the git blame command. To run the git blame command, type git blame and the name of the file. In this case, feature.js. After pressing enter, Git returns a list of all changes on the file. To understand what is happening, let's break down the blame messages and go through it line by line. Firstly, let me guide you through the format of each line. Every line will start with the ID, and then the author, the date and time when the change was made, and the exact line number where the change occurred. Then the actual change or content is also returned. The ID is a reference ID of the commit. The same ID might appear in several lines. This happens when a single commit has been made by the same developer. The author is the person who created the commit. The timestamp is the date and time when the changes were committed. Line number represents the location in the file or the exact line where the changes were made. The content is the code that was added to the file. Now that you know the meaning of each line in the blame output, let's explore a real example. In this example, you will check who made changes, when the changes were made, and also what changes were added. For the purposes of demonstration, I will be using a public repository called mkdocs. mkdocs has various different contributions from many different developers, so it's a good way to see a log file from all the changes of specific files. To begin, I will check inside the directory by using the ls command and passing in -l to get a list of all the available files, and I'll just pick one. The file I will use is called setup.py, which is a Python file. So in order to examine the different changes to that file, I create a command called git blame and then pass in the name of the file, setup.py, and press enter. The output will list all the changes made by all the different developers. It will also indicate the timestamps and line numbers as well as the actual changes that were made. Now I will talk you through the output. Starting from the left of the list is what's called a #ID. It just represents the commit of when a change occurred. Then the name of the developer who worked on the file is listed, and then you have the timestamp when the change went in. Next is the line number in sequential order. And finally, the actual change that was implemented. I can scroll through the list of changes all the way to the end of the file, depending on the size of the file or whatever number of lines it has. If I want to exit out, I click on Q. This will clear the screen to make it easier. Take note that git blame on its own and by passing the file name will list the entire file. In a lot of cases, you will work with very large files, and then you'll need a way to abbreviate the output or chop it down based on, say, line numbers. Fortunately, git blame offers a flag for that. To do this, I type git blame and pass in the flag of -L and specify the starting line number and the end line number. I will type 5,15, then pass in the file name again, setup.py, and press enter. This time, a smaller subset is returned that only starts at line 5 and ends on line 15. The output indicates that there are 4 different changes made by 5 different developers across these lines. Let me give you a few more tips around git blame now. Firstly, you can change the format of how the list is displayed. This is similar to what you can do with the ls command on the Unix commands. You can also pass in a -L flag for changing the output itself. So again, let's run git blame -L followed by the file name and press enter. This time, there are a few changes to the output. For instance, the #ID is in its full-length form. It's not in the shortened version. The output is now a bit more detailed. You can also control if you want to show email addresses or change the date format. These are the examples of the various things that you can do. Secondly, another aspect of using git blame is that you can see detailed changes or the actual commit changes of a specific #ID. To do that, I will run a git blame command on that file again in order to copy a #ID from the output. Now I will use that with a git log -p and pass in the #ID and press enter. This gives you the actual change that occurred. Just to clarify, git blame will display to you the point where it was changed. Git log will give you the detail of the change. I always use the two in conjunction to get more details about what changes occurred. You've reached the final video in this lesson on creating a repository with forking and the end of the Git module. Let's take a few moments to recap on what you've learned. You now know how to explain the principles of Git and utilize a GitHub repository, including branching and merging code. Perform a local install of Git on a Windows operating system. Create a new repository in GitHub and clone it to a local machine. Explain the fundamentals of Git and outline the Git workflow. And identify the differences between remote and local repositories in GitHub. Explain what the git add and commit commands do and describe how they work. Push content to remote repositories with git push and retrieve content from remote servers using git pull. Keep lines in your workflow clear and stable with the use of branches. And explain how head is used in Git to identify the current branch you're working on. Compare changes across files, commits, and branches using diff commands. Examine changes to files and identify their author with the use of blame commands. And create a repository with the use of forking. You're now familiar with Git, GitHub, and creating repositories with forking. Great work! In this course, you were introduced to the practice of version control. Let's do a brief recap of what you covered. In the first module, you learned about how different version control systems and effective software development workflows enable modern software developers to collaborate across the world without messing up each other's code. You gained knowledge about the history of version control and know how version control or subversion is used to bring order to the chaos of massive software projects that have the potential for mistakes and bugs. Next, you learned more about the various systems, tools, and methodologies that are leveraged by software developers to collaborate successfully as part of a global team. You explored how to resolve conflicts in Git and that version control plays a crucial part in the development of software. You then moved on to investigate the difference between staging and production, and that a staging environment should mimic your production environment. In Module 2, you learned about how to use the command line to execute commands in Linux. You were introduced to what the command line is and learned to use commands that traverse, create, rename, and delete files on your hard drive. Then you learned how easy it is to use piping and redirection to create powerful workflows that will automate your work, saving you time and effort. Finally, you explored the command line further, discovering standard input-output streams, flags that can be used to change the behavior of a command, and grep. In Module 3, you developed a strong conceptual understanding of the Git technology and how it is used in software development projects to manage team files. First, you learned how to install Git on various operating systems, and then how to connect to GitHub via HTTPS and SSH before creating a GitHub account. Next, you gained a practical understanding of how Git works, including creating and cloning a repository, add, commit, push, and pull. You also explored how to use a repository and some concepts associated with workflows, such as branches, blame, and forking. Finally, the ungraded lab is an opportunity to complete a practical version control exercise by forking a repository, creating a branch, and committing a change. It also includes staging your changes and opening a pull request with a source repo. Well done on completing this recap. Now it's time to put into practice all that you've learned. Are you ready to proceed? Good luck. Congratulations on completing the Introduction to Version Control course. You've worked hard to get here and developed a lot of new skills during the course. You should now have a great foundation in the different version control systems and how to create an effective software development workflow. And you've also demonstrated your skill set by managing a project on GitHub for the graded assessment. Following completion of this course, you are now able to implement version control systems, navigate and configure documents, files, and directories using the command line, create and manage a GitHub repository, and manage code revisions. The key skills measured in the labs showed your ability to determine the current working directory and make and change directories and files using the command line, create, clone, commit, and push to a repository, create a repository with forking, and manage a project on GitHub. So, what are the next steps? You've established a good foundation so far, but there's always more to learn. Whether you're just starting out as a technical professional or student, this project will enable you to prove your knowledge and ability. Your project experience shows employers that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your educational progress. Once you've completed all the courses in this professional certificate, you'll receive Coursera certification. Certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Congratulations once again on reaching the end of this course. It's been a voyage of discovery. Best of luck, and do continue to pursue your own learning objectives to their final goal.